Hello, boys and girls. Today you are going to need your unit rate booklet. And you're going to need to turn to the page that has ratios and proportional relationships. Okay, and it has the Robert Wadlow picture right here. And we're going to do this together. So make sure you have that as well as a calculator. All right? So make sure you have those things. And when you do, oh, and you need headphones, obviously. All right? And then we'll get started. Ratios and proportional relationships. Ratios and unit conversion. So one of our Common Core goals is to use ratio reasoning to convert measurement units, manipulate and transform units appropriately when multiplying or dividing quantities. And here is our question. Robert Wadlow currently holds the record as the world's tallest man. He was 107 inches tall. Calculate Robert's height in feet and inches. Show your work. Hint, 12 inches equals 1 foot. Now, what do we know? We know that he was 107 inches tall, and we're going to convert that to feet and inches, and 12 inches equals 1 foot. Now, keep the video playing for this. I'm going to set a timer, and then the timer will go off. So solve this problem as the timer is playing. And if you see the box down below, it's going to start to fill in with a rainbow color. Okay, let's see how we can solve this problem together. Now, you may have just used a calculator or long division. Because this is ratios, we're going to see how you could solve it with a ratio. Now, previously we asked what two things are we comparing? And we have inches and feet. So if you have not done this, I'd like you to write this down in your booklet. Inches over feet. The ratio that we have is that 12 inches equals 1 foot. Robert Wadlow is 107 inches. We want to know how many feet that is. So how do I get from 12 to 107? That's kind of difficult. So we can actually go down. How do I get from 12 to 1? Well, we divide by 12. I'm going to divide 107 by 12. And when I do, I get 8 remainder 11. The 8 is how many feet Robert is. 11 is how many inches we have left over. Robert is 8 feet and 11 inches.
Making ends feet is certainly a big job when it takes size 39 shoes to fit them. Two into one do go. Here's the owner, Robert Wadlow of Chicago, who at the ripe old age of 17 stands 8 feet 4 inches in his socks, and incidentally seems to be quite beyond the reach of young women. Every time young Robert goes through a doorway, he scores a duck. And this is Robert's father, a mere dwarf of 6 feet.
There are certain items in the Guinness Book that can only be classified as classic Guinness. Robert Wadlow Jr. is definitely a classic. Although he died in 1940, Robert's record has never been broken. Let's take a look back at the world's tallest man. He was just under 9 feet tall, 8 feet 11 and 1/10 inches, nearly 2 feet taller than NBA All-Star center Shaquille O'Neal is today. And the world could barely accommodate him.
I had a duck to go through all doorways. No room on a bus, no room on a train, no seats, airplane. Everything was made for a person 6 foot or under, maybe 9 foot.
Robert Wadlow, tallest man ever, born 1918, Alton, Illinois. As his average-sized parents watched in awe, it didn't take long for Robert Wadlow to grow up and up and up. By age 5, he was already 5 feet 4. By 10, he was 6'5" and towered over his teachers.
But I went in there to teach, and I still don't remember a single thing I taught, because when Robert walked in there and sat down with those great big old feet sticking out, I kept looking at him, and he got out his paper and he put it on the desk. It was a regular notebook-sized paper. He put that great big hand on top to start writing, and I couldn't see the paper anymore.
Robert longed to be normal, and except for his size, he was. He even joined the Boy Scouts.
Just a regular boy, like any other boy, only larger. His mischievousness was just like any other. He'd take your hat and put it up in chandeliers where you couldn't get a hold of it.
He probably wished that he was as tall as he was and wanted a normal life, which he couldn't possibly live.
When he was 12, doctors found he had an overactive pituitary gland, the source of human growth hormones. Corrective surgery was dangerous and not sure to work, so his parents let nature take its course.
I'm Robert Wadlow, 12 years old, and weigh 240 pounds, and I'm about 7 feet tall. These boys grouped around me are about the same age as I am. They go to the same grade.
2 years later, when he entered high school, he was 7'5" and used to being teased.
And he always took it so well. But in spite of everything, his ears would turn red, and he would chuckle, and he would look terribly embarrassed. But I never did see him appear angry.
His size made him too awkward to play basketball. He had circulation problems in his huge feet and was sometimes ungainly when he walked. Shoes were a problem too. He had to have them custom made. The last pair made for him were size 40.
I wear the largest pair of shoes ever made. And when I kick somebody, they stay kicked.
In Alton, Wadlow was well-liked and treated with respect. But elsewhere, he was the object of unwanted attention.
He couldn't go anywhere without being stared at and drawing a crowd. Some people would bother him, because of his height. Well, they might come up behind him and pinch his leg or something else, or maybe even try to kick him, on the shins. Make sure he wasn't on stilts.
His sanctuary was home with his family. His younger brother Harold, the only remaining member of the family, always admired him.
He was the best big brother anybody could ever have. He was a good person, quiet person, loving, caring.
Wadlow never stopped growing. He was 8'4" when he graduated from high school. He then enrolled in college and joined community groups. The Masons had to have a special chair built for him. You get a true sense of Wadlow's immense scale when an average-sized person sits in it. When he was 20 and 8.5 feet tall, Robert Wadlow began doing promotional tours for the company that made his shoes. He may not have enjoyed fame, but he liked traveling and the perks of being on the road.
We did go out on double dates. We'd go to a theater or a nightclub, usually for dinner and then dancing. We laughed, we giggled, we just had a wonderful time. Robert never took advantage of being a popular person and one that was in the limelight. He never used his popularity to take advantage of anyone.
He died in 1940 from a foot infection caused by a metal brace he wore to strengthen his ankles. 5,000 people attended his funeral. It took 12 men to carry his casket. Though Robert Wadlow was only 22 when he died, this gentle giant led a giant life.
He led what I would have called an accelerated type of life. He traveled more, saw more, met more people, from political life, sports figures, movie stars. He did more in his short life than most people do in 2 or 3 lifetimes.
The man Guinness currently lists as the tallest man is Haji Muhammad Alam Chana. This 7'7" and 1/4 inch Pakistani died recently in a New York hospital. The tallest man in the world now is just measured North Korean Michael Rye, who is 7 feet 9 inches. A foot shorter than Robert Wadlow, the basketball-playing Rye is said to be the object of great interest in the NBA.
So, Robert Wadlow is the tallest man who ever lived. Sultan Kosin is the tallest current living man. In 2009, Sultan became the first man over 8 feet to be measured by Guinness World Records for more than 20 years. In fact, Guinness World Records only knows of 10 confirmed or reliable cases in history reaching 8 feet or more. The part-time farmer from Turkey was found to be a towering 8 feet 1 inch in height, and he took the iconic title of tallest living man. 2 years later, the 26-year-old was measured again, by which time he had grown to a staggering 8 feet 2.8 inches.
The Golden Gate Bridge is certainly one of the most iconic and beautiful structures in the world, but what you may not realize is that it terrified a lot of drivers. Well, now that's all changed. For the first time ever, the bridge has a barrier that separates northbound from southbound traffic, and what makes this one so unique is that it moves. This is a specialized truck that can move these 3,500 concrete and steel blocks across the lanes of traffic. It's sort of like a zipper. And the idea is to keep traffic moving smoothly, but also stop head-on collisions. This is very expensive technology. The system costs $30 million. The way it works is the trucks move over each barrier. Each one is 1,500 pounds. They're lifted up and moved over to the other side of the lane before they're set down. These trucks, they may be really strong, but they're not exactly speedy. The top speed is 10 miles an hour, and they get just 5 miles to the gallon.
The bridge is very unforgiving. If a motorist is traveling on the bridge, someone coming the opposite direction, if they're distracted momentarily, would slam into him. It would be a horrific head-on accident.
The bridge is more than a mile long, and I tell you what, driving across it could be a pretty scary experience, especially if you were in that far left-hand lane. There used to just be plastic pylons there, so you were always at risk of somebody swerving into your lane of traffic and hitting you head-on.
When you visit the city of Philadelphia, there are many bridges that go into the city, out of the city, and you will see concrete barriers. They have a machine very similar to the machine that you just saw that moves the concrete barriers to the left or the right to change the number of ingoing and outgoing lanes. So in the morning, we would like to see more lanes going into the city for rush hour because people are going to go to work. And we want traffic flow to be easy going into the city. At the end of the day, everybody's leaving and going home. So we want more, we want to make it easier for people to leave. So then we want to move the concrete barriers to create lanes going out of the city. And the vehicle that does it is called a zipper because it kind of looks like a zipper. So next time that you're on a bridge, take a look to see if you can see a vehicle like the one that we just saw. All right, and this is our problem for today. Mark is picking up a load of concrete highway dividers. Each divider weighs about 3 tons and 1,500 pounds. So I'd like you to draw a little box, and my pen is not working, so I'm going to, this is going to be rough. You know, draw a little concrete barrier. This barrier is 3 tons and 1,500 pounds. Total. So write that down. Sorry, my handwriting's not so good. So for example, when you were born, you might have been 7 pounds, 3 ounces. Okay, so this is 3 tons and 1,500 pounds. He can haul a load that weighs up to 72 tons. So here's his truck. Draw a little truck. His truck can hold 72 tons. All right. Determine the maximum number of concrete dividers Mark can haul at one time. Show your work. Now, this is a little timer down here, all right? So you don't have to pause the video. I want you to give this a try to figure out how to solve it. Now, the one thing here is that we have tons and we have pounds. 1 ton equals 2,000 pounds. So my suggestion would be to convert everything to pounds and then solve. So find out how many pounds a concrete divider is and find out how many pounds he can haul and then solve your problem. All right, so you may begin, and then when the time runs out, we will go over the answer. Okay, time is up. All right. Now, on your, or in your booklet, you have some questions to answer. So let's do that together. How much does one divider weigh? One divider weighs 3 tons and 1,500 pounds. So write that down. Convert this weight to be in pounds only. So we have part of this weight already in pounds. Okay, but the 3 tons is not in pounds. Okay, so we have to convert 3 tons into pounds. So 1 ton equals 2,000 pounds. 3 tons is going to equal 6,000 pounds. So 3 tons will equal 6,000 pounds. And we still have to add the 1,500 pounds to that. So with your calculator, or actually you could just do this in your head, add 6,000 plus 1,500, and you should get 7,500 pounds. So one divider weighs 7,500 pounds. We know that Mark can haul up to 72 tons. Let's change that to pounds. We know that 1 ton equals 2,000 pounds. So for every 1 ton, we have 2,000 pounds. So we multiply by 2,000. We're going to multiply 72 times 2,000, because we multiply times 2,000 here, and we get 144,000 pounds. And that is what Mark can haul. One divider weighs 7,500 pounds. Mark can haul 144,000 pounds. So how many dividers can Mark haul? This is a division problem. We're going to divide 144,000 by 7,500, and we get 19 and 2/10. This means that he can haul 19 full dividers and 2/10 of a divider. Do you think he's really going to divide or break apart a divider? I don't think so. So we can say that Mark can haul 19 dividers in all. Well, that brings us to the end of our lesson today, and I hope that you have a wonderful day, and I will see you tomorrow. Bye-bye.